One of the students in my MAE 3013 summer class has asked the question about one of the homework problems. That homework problem is a steady state heat conduction problem in which we have this grid of points with XY spacing that is uniform, and these four temperatures in the middle of this region are unknown, and we've been given equations that tell us the temperatures on the boundary. The author shows the solution of shows the equations written in linear form. We'll talk about that in just a minute. The author gives the solution of the equations, and for this particular problem, our partial differential equation can be approximated by a difference equation. We're approximating the second derivatives with differences, and here is the difference equation for the 2D steady state heat conduction problem, for the right hand side equal to 0. And so the easiest way to explain this is to take this grid and set it up here. And so I'm going to put right here, I'd rather call it T1 actually, temperature 1, temperature 2, temperature 3, and temperature 4. Now, it says on the left the temperature is equal to 0. So let's put 0, 0, 0, and I'm going to put 0 there. On the lower edge, it's 27 minus y squared. Okay, where, let's see, no, it's x cubed on the lower edge. So I'm just going to put some x values here. X is 0, 1, 2, and 3, as given in the problem statement. Now I'm going to center everything up so it'll look a little bit nicer. And over here on the right, sort of far away from the problem, I'm going to put the y values as given in the problem statement as 0, 1, 2, and 3. And so y is heading upward. And now on our boundary, since it says x cubed on the lower edge, then 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, and 3 cubed is 27. That takes care of the bottom boundary temperatures. Let's see. 27 minus 9y squared on the right. All right, so y is 0 on the right. So 27 minus 9 times 0 squared is 27. 27 minus 9 times 1 squared is equal to 18. 27 minus 2 times 9 squared is a 9. And 27 minus 9 times, oops, let's be more careful about this. So 27 minus 0, 27 minus 9 times 1 squared is 27 minus 9, that's 18. 27 minus 9 times 2 squared, 27 minus 36 is going to be a minus 9. And then 27 minus 9 times 3 squared, 27 minus 9 times 9, 27 minus 81 equals 27 minus 81. I'm just going to put that formula in there, which is a minus 54. And then it says on the upper edge, x cubed minus 27x. So when x is 0, we get a 0 on the upper edge. When x is 1, this is 1 cubed minus 27 times 1. Okay, so it's going to be a minus 26. And here, this one is going to equal 2 raised to the 3 power. minus 27 times 2 is equal to minus 46. And then I'm going to just double check this one because I think they set everything up so that it behaves nicely. When x equals 3, it would be 3 cubed equals 3 cubed minus 27 times 3. Comes out to minus 54, which is what we got from the other boundary. Okay, so now what we have is this grid with all the boundary temperatures filled in. I'm going to go ahead and highlight the boundary temperatures with color to make it appear a little more distinct. So I'm going to fill those with a gray. These are the boundary temperatures. Those are known and constant. I've got 4 unknown temperatures. Now, my pattern equation for this, let's just move it over here now, says that at any xy location, let's pick this location right here where the cursor is, then it says it is true that the neighbor at x plus h, this is the neighbor above, plus the neighbor, sorry, x plus h is to the right. The neighbor to the right plus the neighbor above plus the neighbor to the left plus the neighbor below minus 4 times the point that I want to solve equals 0. This equation, when I apply it to T1, would say the neighbor on the left is 0 plus T2 plus T3. Let's see. So I did left and right, bottom, and then minus 26, and then plus 4 times T1 equals 0. And now when I rearrange, I'll rearrange these equations to put them in the T1, T2, T3 order in just a moment. But let me write the equation at T2. The equation at T2, okay, but one thing you can see is that let's see, and actually this is a minus 4. I've got that wrong. Minus 4 T1. Minus 4 T1 equals 0. And let me see, that minus 26 is going to go over as a positive 26. Okay. Yeah, one of those was negative, one of those was positive. I was trying to look ahead and see the answer. That's the T1 equation. The T2 equation says neighbor to the left, so I'm going to leave my cursor right there on T2 right now. Neighbor to the left, which is T1, plus the neighbor to the right, which is minus 9, plus the neighbor below, so plus T4, plus the neighbor above, which is a minus 46, minus 4 times T2 that I'm working on right now equals 0. That's my next equation. And then working on T3, neighbor to the left is 0 plus T4, that's the neighbor to the right, plus 1, that's the neighbor below, plus T1, that's the neighbor above, minus 4 times T3 equals 0. And then finally, my T4 equation, centered on T4, is neighbor to the left, T3, plus 18, that's neighbor to the right, plus 1, plus 1, that's the bottom neighbor, plus T1, that would be everything, no, sorry, plus T2. Let's double check this. Neighbor to the left, neighbor to the right. Neighbor below, sorry, that's a 6. Neighbor below is a 6. The neighbor above T4 is T2. Then minus 4 times T4 equals 0. Now, we can rewrite the first equation, and let's put them in T1, T2, T3 order. And it's going to be a minus 4 times T1, then plus 1 times T2, plus 1 times T3, plus 0 times T4 equals a positive 26. And you see, oops, I don't want that equal sign there. I just want that to be, okay, because I started typing this as an equation, it got confused. Okay, so minus 4 times T1 plus T2 plus T3 equals a positive 26. That's that equation. Oh boy, I need to put this in quotes. I think that works. Let's try it. Maybe it doesn't. I don't really want the quotes to show up, but if that's what it takes, that's what I'll do. Let's try a single quote. Alright, that looks better. Now this next equation says T1, I don't have to have capitals, do I? Too much trouble. T1 minus 4T2 plus 0T3 plus T4 is equal to a 46 minus 9, minus 46 and a minus 9 is a minus 55 on the left. That's going to equal a positive 55 on the right. And then the next equation, and I think you can see how these equations are starting to boil down into the form, let's see, although the naming is different and the order might even be slightly different, they're starting to boil down into this form where the P11 I called T3, P21 I called T4. Okay, but the equations are starting to shape up. And actually, we wouldn't even have to rewrite the equations. We could simply leave them in this form. I'm just trying to get them as close to this form as possible, but I may have to, you know what, he didn't even use the same names. He called them P1, P2, P3, P4. Not sure what his naming order was. It may have been different than mine, which will make the equations just look a little different. Alright, so I've got a T1 minus 4T3. So T1 minus 4T3 plus T4 is equal to a 0. That's it. It came from the T3 equation. You got 3 of those in it. Is equal to a minus 1. So you can see we're duplicating the constants over on the right hand side. Then finally this equation, it doesn't have T1 in it. It's got T2 plus T3. Let me see. T2 plus T3 minus 4 times T4 is going to have the constant term 18 plus 6. Let's see. 18 plus 6 is 24. Going to the other side equals minus 24. That's the first constant that I didn't nail, and either he made a mistake or I've got the wrong temperature here, so let me just double check it. And the bottom temperatures, let's see, is x cubed, so it's yes, this is an 8. And I didn't need that anywhere else, so that's an 8. That is an 8. And 18 and 8 is 26. So this one is going to be a minus 26. I think you can see I've matched his constants. There's certainly some 1, minus 4, 1 patterns developing here. And the only reason my equations might not match his perfectly is I have them in different orders. I've got the 26 equation here and the 55 equation second. So the equations are in different order, and I might actually have my variables named differently than his. Now, how would you go about solving this thing? 2 ways. Put these equations in matrix form, as he did here, and solve them. The other is we could use a Gauss-Seidel iteration by presuming a starting value, and I'm just going to do this by hand. Let's presume that we're going to start with initial guesses of, let's pick 10. 10, 10, 10, and 10. Now, with a Gauss-Seidel, I would be solving each equation that has a 4 in it for its variable. It would be the right way to do a Gauss-Seidel. That's the biggest constant in the problem. That would be equivalent to solving this equation for the term that has the 4 in it, which is always the term where I'm centered. And Gauss-Seidel would say that take the minus 4 to the right with the u term, then divide both sides by minus 4. It would say that this u term is the sum of the 4 terms around it divided by 4. Well, that's the average of the 4 terms around it. So, starting with this initial Gauss-Seidel guess, this 10 is going to become a minus 26 plus 0 plus 10 plus 10 divided by 4. We're going to type that in. Equals minus 26 plus 10 plus 10, and all of that, got to type my parentheses up here, all of that divided by 4. And that one makes this one 11.5. Now I move to this term. This term is simply going to become the average of these terms that are around it. And that's going to be a minus, parenthesis, minus 46 minus 11.5 plus 10 minus 9 divided by 4 is that term. Then this term is going to be the average of its 4 neighbors, north, south, east, and west, or above, below, left, and right. And so that one is going to equal to a minus 11.5. I need to put a parenthesis in it, and you can't see me typing it, but that's okay. Minus 11.5 plus 0 plus 1 plus 10 divided by 4. Why didn't that calculate? I didn't put an equal sign in front of it. So there is that one. You can see it heading closer to those zeros. And then this one, and you see that when I calculate this one, I'm going to be using calculated values in the neighborhood. It's the average of its north, south, east, and west neighbor. And so this one is going to be equal to, equals parenthesis, minus 14.125, and then minus 0.125 to the left, plus 8 below, plus 18 to the left. All of that divided by 4 is that. I've done one Gauss Seidel iteration. Now to carry it on forward, I'll do this term, that term, this term, this term. Again, just continuing to average the 4 neighbors around it. I'm not going to do the entire step, but I'm going, because I want to get this video posted, I will say that this term now equals parenthesis minus 26 plus 0 minus 0.125, which is below, minus 14.125, which is to the right. All of that divided by 4. Wow, how did that? 11.5. I don't see how that became a 0. Minus 11.5 plus 11. Oh, that's one. Maybe it's just not printing very many digits. Oh, no, I got an equal sign in there. Minus 26 plus 0, and then minus 0.125 minus 14.5. Okay, that's better. I had an error in the equation is what it was. I've got this new value, then this new value, and this is the last one I'm going to do. This new value is equal to parenthesis minus 46 minus 10.0625, that's the neighbor to the left, plus 2.9375 plus 2.9375 minus 9, parenthesis divided by 4 is that term. Okay, then I can do this one and this one. I think I'm going to stop the video so I can get it posted, give you a chance to see it. And so I'm going to